Okay, Assalamualaikum, salam sejahtera. My name is Cikgu Nur Muhammad. Okay, so this is IB Chemistry, Topic 5, Energetics. So on this video, I want to explain about the Hess Law. Okay, the learning objective is students must understand what is enthalpy cycle and what is Hess Law and how to calculate the enthalpy change by using the Hess Law. So this is an enthalpy cycle, or the another name is Hess cycle. Okay, it is basically a restatement of the law of conservation of energy, which is the energy cannot be created or destroyed. So if a reaction can happen in two different ways, the overall energy change for the first way must be equal to the overall energy change for the second. Okay, in this case, okay, we have a reactant. We know that in chemical reaction have reactants and final products. This is a reactant and B is final products. This is called as main root. Right? This is called as main root. Okay, when energy, okay, inside energy maybe have a reaction between A and B. So it will produce C plus D. Okay, when A react with B, produce C and D, it will produce heat change that called enthalpy change 1. Okay, but maybe A and B also, when it react with each other, it can produce the another product such as E plus F that we call C. Okay, so when A and B produce E plus F, it will produce the enthalpy change 2. And E and F react together or react with the another elements, and it will produce the final product, which is B. And it will produce the enthalpy change delta H3. Okay, uh, and also at the same time, maybe A also, A react with B, it can produce the another products such as G plus H, or we call it as D. Okay, and it have a different enthalpy change that called delta H4. And the same concept, GH react with the another element and it will produce the another product, which is I and K. And I and K react with the another element, produce the final product, which is B. Okay, what I'm trying to say that, okay, this main root, okay, this is called main root, which is the main chemical reaction. Okay, and the another chemical reaction can become, okay, this is the second root. Okay, this is the second root. Okay, okay, the second root is a hidden chemical reactions, meaning that during the chemical reaction A to form B final product, it has the hidden chemical reactions before achieve final product. Maybe A react with B, produce E and F. After that, it produce C and D. Okay, this hidden chemical reaction is called intermediates. Okay, it's called intermediates. See, same concept to the D and E. This, all of this is called intermediate or hidden chemical reactions. Okay. So why this happen? Because it depends on the law of conservation of energy, which is the energy cannot be created or destroyed. Okay. Right. So okay, this is the main root. Okay. AH2 and AH3 is the second root, and we have the another A to D to E and to the B is the third root. Okay, root 3, and this one is root 2. Okay, during the enthalpy cycle, okay, inside the enthalpy cycle, we must know how to identify the root. Okay, make sure the initial returns, make sure the roots are starting from the same initial returns. Okay, I label it as 1. Okay, in enthalpy cycle, it have a series of chemical reactions. Okay, and at the end, they are still produce the same product. So the main root is root 1. Okay, and the second root is the root 2. Okay, the root 2, and the okay, so from the root 2, okay, it start from the A to B and to C, and finally it produce the same product. Okay, from A produce D, become E, and finally produce the same product. That is why we call it as root 3. Okay, and please remember that sum of sum of enthalpy change from root 1 must equal to sum of energy in root 2 must equal to sum of energy in root 3. Okay, so in root 1 we have delta H1. So it equal to delta H2 plus delta H3 in root 2, and it also equal to delta H4 plus delta H5 plus delta H6. That's why in enthalpy cycle or Hess cycle, it is important to identify the type of root. How many root inside the Hess law? Okay. Next, okay, you are already used this without knowing when used. Okay, before this we calculate enthalpy change. Okay, by using the enthalpy change of formations. Or we also can calculate the enthalpy change of reaction by using enthalpy change of combustion. Okay, this formula we use it during to calculate enthalpy change of reaction when involve one chemical reaction only. But for the complex chemical reaction that have a few series of chemical reaction, we have to use the Hess law to calculate standard enthalpy change of reaction. Okay, we cannot use the formula of enthalpy change of formation or formula enthalpy change of combustion. Okay, this is a complex reaction. Okay, that are made up from more than one series of chemical reaction. That's why we have to use Hess law. Okay, in Hess cycle or enthalpy cycle, okay, maybe they are made up from the heat enthalpy change of combustions. Maybe they have enthalpy change of formation, or maybe they have both of enthalpy change of combustion or enthalpy change of formation. Okay, this is return and produce a product. Okay, let's say this is enthalpy change of formation. Okay, enthalpy change of formations. Okay, maybe for the second root, okay, this is root 1. Okay, root 1. Maybe for the root 2, okay, this root 2. Root 2, it have enthalpy change of combustion, enthalpy change of combustion. Okay, so inside the enthalpy cycle or Hess cycle, maybe it have enthalpy change of formation, enthalpy change of combustion, or both of enthalpy change formation and enthalpy change of combustion. Okay, Hess law. What is Hess law? Hess law said that the enthalpy change for the reaction that is carried out in the series of steps is equal to the sum of the enthalpy change for the individual steps. Okay, let's say, okay, please look at this example. Okay, reaction A, reaction C, and reaction B. Let's say, okay, this is the main root. Okay, this is the main root. Why I said this is main root? Because this is reactant and directly produce product. And they are the second root, which is before A form product C, it form product B, and then form a product C. Okay, this is root 2. Okay, and this one is root 1. Okay, how to identify root 1 and root 2, root 3, and so on. Okay, make sure identify the first return and the final product. Okay, each root or each series of chemical reaction must start from the same return and end with the same products. Okay, so as I said before, AH3 AH3 is equal to AH1 plus AH2. Okay, so there are a few rules to using Hess Law. First, Hess Law can be used to work out unknown enthalpy change from known ones. It is important, okay, to student to come out the formula from the series of chemical reactions. Okay, because from these equations, okay, we can identify the unknown. Let's say we don't know the enthalpy change 1, and the information given are only at enthalpy change 3 and enthalpy change 2. So we can calculate the enthalpy change 1. And the another problems, okay, maybe we don't know what is the value of enthalpy change 3, but the question give the information for enthalpy change 1 and enthalpy change 2. So we can calculate the enthalpy change 3. Okay, so this is first rule. We can calculate the enthalpy for unknown enthalpy change. Second, the enthalpy change of reactions is independent of the pathway of the reaction. Okay, so the sign of enthalpy change is depend on the arrow. Okay, C. Add when going with an arrow, subtract when going against an arrow. Okay, as example. Okay, example. Okay, let's say the question asks, okay, find the value of delta is 2. Delta is 2. Okay, if the question asks the delta is 2, please state which one is return 1. Okay, this is our return. And C become products. And this is root 1. Okay, remember that root 1, root 2, or root 3 depends on what type of enthalpy change that we want to calculate. Okay, this is root 1. Root 1. Okay, and remember that start from the same return and end with the same product. So this is second root. Okay, this is second root. Second root. Okay, so the formula is delta H2 equal to, okay, the flow is start from the return and end with the same products. Okay, from B to A, okay, the arrow is opposite, right? Okay, when the arrow is opposite, so delta H1 become negative. Negative H1 and plus, okay, H3, okay, it go through the same arrow. Okay, go through the same with the same arrow. So the sign for delta H3 is remain positive. Okay, so this is the formula how to calculate delta H2. Okay, it depends on what type of enthalpy change that we want to calculate. Alright, so the next problem. Okay, this is a few example of Hess Law. Okay, let's say I said, okay, this is example one. Okay, we refer on the example one. So I want to calculate the delta H3. Okay, find the delta H3. So this one will become return. Return and CD will become product. Now identify which one is root 1. Root 1 is here. This is root 1. And the flow is from return to the products. So which one is root 2? Okay, root 2. Remember that start with the same return and end with the same product. This is root 2. Yeah. And the flow is okay from return and end with the same product. Okay, we come out the formula. Now delta H3 is equal to, okay, from EF to AB. Okay, the direction is opposite. Okay, with the direction H2, now delta H become negative because opposite direction, plus delta H1, okay, from AB to CD, okay, it has same direction, so still remain as positive. Okay, this is a formula how to calculate delta H3. Okay, okay, for the second example, let's say I want to calculate the delta H1. Delta H1. So AB will become our return and CD become our product. Okay. And this is root 1. Okay. This is root 1. So where is root 2? Root 2, remember that start from the same return. Okay. And end with the same product. So the arrow is, okay, from AB to CD. Okay, let's come out the chemical equation. Delta H1 equal to, okay, the direction is equal for delta H2, so remain positive, plus, okay, AH3 have opposite direction, so negative delta H3 plus, okay, same direction with the delta H4 plus delta H4. And finally, delta H2 minus delta H3 plus delta H4. This is the equation. Okay. Alright. Okay, this is an example for enthalpy cycle or Hess Law cycle. Okay. Delta H3 we know the value. Delta H2 also we know the value. And what is the value for delta H1? Okay, so this is our return and this one is product. Okay, so this is our main root 1. Okay, so delta H1 equal to, okay, now from the same return move to the same product. Okay, so the direction is equal to for delta H3 plus, but the direction is opposite way with the delta H2. Okay, so negative delta H2. Okay, so delta H3 minus delta H2. Okay, this is the formula how to calculate. Now, insert the value of enthalpy change. -1, 6, 4, 6, minus negative 1, 3, 6, 7. Okay, so the answer is negative 1, 6, 4, 6, 1, 3, 6, 7. Negative 279. Negative 279 kilojoule per mole. Okay. Okay. Okay, next. Okay, sometimes the question not give the enthalpy cycle or Hess cycle, but they give a list series of chemical reactions. Okay, how to calculate the enthalpy change? Okay, by using the Hess law. Okay, in this question, okay, they give us a series of chemical reaction. This is the given. Okay, and calculate the delta H for this chemical equation. Okay, how to calculate? Okay, first step. Okay, rearrange series of equations according to chemical equation of question. Okay, this is our question. Rearrange. Okay, second. Uh, if product and reactant is switch each other, okay, sign of enthalpy change also convert. Okay, number 3. Okay, delta enthalpy change times with the number of coefficient number. Okay, okay, let's look at the exercise. Okay, alright, so the first step, okay, identify the reactant. Okay, make sure the reactant is 4 iron oxide. Where is iron oxide? This is iron oxide. Okay, so modify this first equations. Okay, FeO produce Fe solid plus 1 over 2 O2 gas, and times with 4 because there are 4 coefficient number, times with 4. That is why the enthalpy change is convert its signs positive 272 and time with 4. Okay, 4 FeO solid produce 4 iron solid 2 O2 gas, so produce delta H 272 times 4, 1088. Okay, positive 1088. Okay, this is first equation. Now look at the second equation. We have the product Fe3O4. So for the second equation, okay, Fe3O4 same as the question, which is located at the products, and the coefficient number is 1. Okay, so there is no any modification for equation 2. So just copy the chemical equation. Gas produce Fe3O4 solid plus Fe solid. Okay, still remain the same. 4. Okay, this is equation 2. Now what we have to do is, okay, plus both the chemical equation, and we can cancel out, okay, any reactant and products that same. Okay, example, okay, Fe3 can be cancelled out, and be Fe, okay, and then Fe3O4, okay, can cancel out. Okay, oxygen we can cancel out. Alright. Okay. Alright. Sorry. There is no iron here. Okay. Okay. My bad. There is no iron here. Okay. Now, just write the reactant and product left. For Fe solid, okay, for FeO solid produce Fe solid plus Fe3O4 solid. Okay, we can refer. This is equation reaction from the question. Okay, make sure it's same as our chemical equation, right? Next, okay, what we have to do is, okay, just total the enthalpy change. Okay, positive 1088 plus negative 1118.4. Okay, what is the answer? 1088.4. Okay, the final answer is negative 30.4. Alright, so I think, okay, that's all for the calculation of the enthalpy change while using the Hess law. Okay, okay, let's recap. Okay, to calculate the enthalpy change from the enthalpy cycle, there are two types of question. First, they give the enthalpy cycle, and second, they give the series of chemical reactions. Okay, uh, alright. So that's all from my explanation about the Hess law. Thank you.